So, so what you are doing is, and I'm doing a little acting right now because I read the question. I'm reading it again, like a rehearsed dialogue. So, a mass of one slug is attached to a spring whose constant is 5 pounds per foot. Initially, the mass is released 1 foot below the equilibrium position with the downward velocity of this, and subsequent motion takes sorry, takes place in a medium that offers a damping force that is numerically equal to 2 times the initial velocity, right? So as you said, we have m d2x dt square, right? Are we good?
Yep.
Then plus 2 times the instantaneous velocity, so that's the damping force. Okay. And then kx, and k is given to be 5. And that equals how much? 8 cosine 2t plus 2 sine 2t. Very good. So, and then they say first that find the initial conditions, right?
Yep.
Okay. So let's find the initial condition, that is 1 foot below the equilibrium position. So this is 1, right? And the downwards velocity is 3 feet per second. Okay, makes sense?
Yeah.
Right? Okay, good. So now first thing we will do is we will create the complementary function by setting this equal to what? 0, right?
Yep.
That's 5x equals 0. So we have s squared plus 2s plus 5 equals 0. So I'm just going to use the quadratic formula because
Doesn't matter like if I use S or M.
no, that's why it's okay. I like m myself. Okay, so this is like 4 minus 20 divided by 2. Am I correct? Okay, so this will be,
Uh,
is that good?
is it -2?
Where is my, oh, minus 2. I'm
Right.
sorry. Yeah, that's correct. That's minus 2. I make, and it's good. Just go careful because I'm making mistake now. Then
Yeah, I might need
negative
to double
7.
check it.
Yeah, so
Is it?
that will be negative. Is that
Yeah,
4i?
yeah. That makes sense.
Right. So what we get is this negative 1, right?
Yep.
Plus
Plus or minus 2i.
2i, right? Good. So our complementary function would be, uh, let's take it to the notebook because it'll be much easier there, okay? All right. So I got the equation. I can write it up, okay? 1 second. So the equation was, but I said it 2 times first. It's a d2. Can you see this here? d2x.
Yeah, I can see you're typing.
Yeah, d2 dt square plus 2 dx dt. No, sorry. Plus 2 dx dt plus 5y equals 8 cosine 2t, right? And then we have what? Plus 2 sine 2t, right? Am I clear?
Yes.
Okay, good. So we found our so if we set this equal to 0, right, and use the quadratic formula, then the complementary function turns out to be c1, right, e to the negative t, okay, cosine 2t, right, then plus c2, the same thing, and here we will have sine 2t, right? Are we good?
Yep.
Okay, good. Now we will apply the initial conditions later but anyways, and we have also seen that x0 equals, I forget so fast, 1 and 3, right? X0 equals 1 foot and x prime at 0 is 3 feet per second.
Yeah.
Okay, right. Okay, very good. So we got that far. And this is my xc. So now we will assume something for xp. Now looking at the form of the function, xp, what looks appropriate for xp? We can say a, right, go ahead.
A
A
cosine 2t
plus
plus.
b.
I think
Yeah.
like I was able to go up to here, but I'm like, do we need to like do x for xp? Do we need to do like add it twice since there's two like functions, or just do it once?
No, this is good enough because even if there are two of them, there will always be linear combination of cosine 2t and sine 2t. So they will turn out to be the same, right?
Yeah. So if I have like multiple trigonometric functions, it's just I only have to do like the xp like once like this.
Yeah, exactly, because it has to be linear combination of cosine and sine. Now, what happens is this, say, even if this was not here, okay,
Yeah.
still you will have to bring sine in, okay? All
Okay.
right, makes sense?
Yep. But what if it's like, well, what if the value of like it's like sine of 3t instead of sine of 2t? Would that change anything?
Yeah, then that will change, yes. So then you will have to do this. Write one as a cosine t plus b sine t, the other one as c sine cosine 3t plus d
Uh,
sine 3t, okay? All
okay,
right,
yeah, that makes sense.
okay, good, very good. Yeah, good question. So here we will write the xp prime, right? Okay, xp prime, come on, xp prime. That's a -2, right? And this will be sine. This will be +2, and this will become cosine, right?
Yep.
And then we got the double prime, right? A double prime here, okay? So that will be 4 cosine, and this will be cosine. The derivative will be -2 sine 2t, so that will make it -4, and we get negative sine, right? Are we good? So what we will do now is we'll just substitute those things in this equation, in the top equation. Let's just bring it over here. Okay, so this is the second derivative, right? Okay, plus 2 times the what? The first derivative here, right? Okay, plus plus what is that? 5 times, right? 5 times the original value that we had. This, and let me just temporarily make the fonts a little smaller. They would not be that bad. Can you see these here or no? I'll make,
Yes, I can.
yeah, because I'll make them big again, okay? All right, and then the right-hand side is simply this, and now it will become smaller because what we are going to do is that we are going to collect the coefficients of cosine 2t and sine 2t. So for cosine 2t, what do I get here is -4a from here, right? Then +4b from this portion, right? And then plus 5a from the last one, right? So this is what we get for the cosine of 2t, okay? Then plus, then for sine, we will get -4b, okay? And then how much? -4a, right? And then what do we get? Plus 5a sine of 2t, right? Did I do it right so far?
I'm not sure. Let me double check.
Why don't I let you look at it for a moment, okay? All right. And let me just attend to something real quick on the other side here, okay? If you don't mind. Okay. Yeah, just one moment. And let me know when you have verified it, okay?
Can you go back to it?
No, don't worry about it. Yeah, here. Okay, good.
Um, I think it should be plus 5b, not plus 5a for the sine of 2t.
Oh, yes, of course. Yes,
I
plus
think
5.
everything else looks okay.
Thank you. Let's hope everything else is good. Okay, so what we have is, no, not 400 is way too big. Okay, 300 is good, right? So here, what do I get? A plus 4b, right? A plus 4b cosine 2t, right? Make sense? Plus negative 4a plus b sine 2t, right? To t, and that equals this quantity right here, right?
Yeah.
Okay, so what we have is a plus 4b is how much? 8, right? And this guy is how much? This guy is 2, right? Are we good? Okay.
Yep.
Okay, so let's work with this. Okay. All right. So, say we did this. Say we multiply the top equation by, say, 4. Am I clear?
Yep.
And add the bottom equation to that. All right. What will we get? We will get 17b on the left-hand side. Am I right?
Yep.
And 32 plus 2 is 34, right?
Yes.
So that's going to give me that b equals how much? 2, right? Am I clear?
Yes.
Okay, so b is 2. And if b is 2, what a becomes then? From both the equations, a becomes
And
then,
a b 0.
yeah, a becomes a 0, right? Okay, so that's an interesting particular solution, right? So we have, okay, that's on the top. So here we have the complementary function, right? So this is the complementary function, okay? Making sense? And then here we have x t, right? Equals this. And then we have what? Plus b was the coefficient of sine, right?
Yep.
So sine 2t, right? Are we good? Okay. So that's all right. Okay. So what we have now is we are going to just make use of our initial conditions, which are these, right? Okay. So these are the initial conditions. So let's use this guy. X at 0 is how much?
It's 1.
1, right? So if I let t be 0 in here, then what will happen? This portion will become a 1, right? Am I clear? Because this
Yes, it's
cosine,
clear.
and these guys will disappear, right?
Yep.
So C1 will be how much? C1 will be a 1, right? Am I good?
Yes.
So what does this become then? This becomes, now let me erase it here. So this is a 1, and we have to determine what now? C2, right? So let's just quickly differentiate this guy. Before differentiating, I don't know, maybe it will help. Let's factor this e to the negative t out here, okay?
Okay.
And then what will happen is, inside the bracket, we are going to get cosine, and this is out, right? Okay, so t plus, that's right, okay. Or in other words, I'm just going to bring it down. I mean, if I was writing on the paper, I don't have to, but I'll just do that here. Okay, see, and that's right. So since x prime at 0 is 3, so what we have is x prime at 0 will be 3, right? And this guy, oh man, that's that. Oh no, I didn't differentiate it yet. I'm so sorry, Aaron. I have to differentiate it, right? And then I can put this in. See this here? I was simplifying xt so that it becomes a little bit derivative friendly. That's what I was doing. Are you with me on what I was?
Can you repeat that one more time?
See, I have xt right here,
Yep.
and this is the derivative.
Yep.
So I wanted to get x prime t, okay?
Okay.
If I left it like this, I'll have to write 4 different terms, right? Because this is the product, this is the product, right?
Yeah.
So I took e to the negative 2 as a common factor, but then I just started rushing and was going to use this guy x prime 0 equals 3 right in here, which would be bad, right? Okay. Like I have to differentiate it before I can use this, right?
Yes.
So that's what I was saying. I wasn't doing that. That was like a very thoughtless thing on my part. So when I differentiate it, I'm using the product rule. So the derivative is this for e to the negative t, right? Say yes or no. Make sense?
Oh,
So,
yes, makes sense.
okay. Now I'm going to leave e to the negative t untouched. Okay. And we get this, right? Are we good? And then we
Yes.
are going to write the derivative of 2 sine 2t, which will be 4 cosine 2t, right? Are we good?
Yes.
And now let's just substitute this. So what we have on the left is 3, right? Okay, so this will be a 1 and this will be a 0. So here I get simply how much? Negative 1. Am I clear?
Yes.
And in the second one, what will I get? Okay. Oh, here I did not differentiate inside. I'm so thoughtless here. I see this was going to stay like this, and this is going to be 2 sine 2t. I apologize, Aaron. I shouldn't have rushed it like this. Okay, I'm trying to rush because I just have to be somewhere, but I should not do it. Okay, don't worry, but we are good. See what I had missed to do? I should have differentiated this second factor, right?
Yep.
Okay, and which I failed to do. So anyways, so when I substitute t equals 0, this is negative 1. This is 1. This is 0. So this will be how much simply? Plus 2c2, right?
Yep.
Okay, and then plus 4 cosine 0, that is, we get 4. So, well, that's that's interesting. Looks like C2 will become 0 then, right?
Yep.
Okay, so if C2 is 0, what is xt then? And C1 was 1, right?
Yep.
So xt is simply this.